Here the first reaction we are going to understand, student, the chlorobenzene, that we are going to understand the first reaction. What is there, student? You are treating with the methyl chloride, right, student? So here is what, student, this is the chlorobenzene Cl, and you are treating with what, student? Methyl chloride. So this compound is there, student, CH3Cl. And what is happening if you are treating with the sodium metal, student? So obviously if you are treating with the sodium metal, so it is going to be out like that, student. So what the compound you are going to get, student? Here this will be the toluene, student, and here is the compound will be 2NaCl, right? The first one is what, student? This is the toluene. Okay, this is the toluene. So here methyl group is there, student, with the benzene. Got it? Now the second equation, if you can see, student, chlorobenzene, reaction of chlorobenzene with the Cl2. This is the electrophilic substitution reaction, student. So that reaction I am writing here. You can see, student, here is the Cl group is there, right? And this Cl group you are treating with the another Cl2. Here is Cl2 is there, right? And in presence of you are taking FeCl3 anhydrous. Each position there is hydrogen in benzene ring. So what will happen, student? This HCl is going to be out. So what the product you are expecting here, friend? This product will be what? Here will be the Cl, student, and that is para position also, that is Cl. So para dichlorobenzene, student. This is what the compound, para dichlorobenzene. This is our product, student. Now we are trying to understand. Here is the nitrating reagent is there, student, concentrated HNO3 and concentrated H2SO4. So third reaction we are trying to understand here. So here is the chlorobenzene, student. If you are treating with the concentrated, student, what is there? HNO3, right? And here you are taking concentrated H2SO4. So what the product you are going to get here, student? That is the Cl is here, student, and NO2 group is going to attach here. So para-nitrochlorobenzene. Here if you are Cl H2SO4 you are taking, student, so this reaction is going to be sulfonation, right? Sulfonation means here is, student, if here is Cl, and here if you are taking concentrated H2SO4. So if you are taking concentrated H2SO4, so it will be the chlorobenzene, student. Here is the sulfonic acid, SO3H, right? Now another compound is there, student, the same one, CH3Cl has taken. So in this case, if you are taking the anhydrous AlCl3, but in the initial here the sodium metal is there, so it was wood fitting reaction. But the CHCl3, this is the Friedel-Crafts reaction, student. This reaction is called Friedel-Crafts alkylation. How the product you can write, student? How you will going to write the product? So Friedel-Crafts alkylation, so here is chlorobenzene, and when you are treating with the CH3Cl, along with that you are taking AlCl3, the product will be what, student? Here will be a Cl, and that is CH3 will there. So 4-chlorotoluene will be there, our product, student. And next case is there anhydrous acid chloride is there. So it is the Friedel-Crafts acylation is reaction, student. So dear student, here is the chlorobenzene, this is the Cl. Now we are treating with the CH3 COCl, right? And then anhydrous AlCl3 you are taking, that is the common. So here the product, if you can see, student, this case the product will be what? So here is the Cl, and here is what, student? C double bond O, and this is CH3. Okay, so para-chloroacetophenone will be the product. Now this is the important reaction, DDT1, right? So chlorobenzene you are treating with the this reagent. Let us check, student. This is the chlorobenzene. If you are writing the chlorobenzene in different mode, we will write, student. How? This is the C double bond O. Here is the hydrogen. Here is the CCl3 is there, right? Of this is what is there? Oxygen is there. So how you can write, student? Here you see chlorobenzene we are writing. Here is hydrogen. This is again, here is the chlorobenzene Cl. Another is there, student. Here you can see, right? This is the hydrogen. Now you can see, student, this is the Cl. Here what will happening, student? The water molecule is going to be out this way. So once the water molecule will be out, the product will be something like that. You can write the product DDT here. Let me try to write here. This is the carbon, here is hydrogen, this is the chlorine. Of course 3 chlorine are there, so this will be the as it is. Here will be the 2 benzene ring will be there, student, right? And benzene ring is although attached with what? Cl group is also attached, this is. And one more you can see, student, here Cl group. Now student, you try to write down the name. Okay, how to write down the name? So here you see 1 2. So it is the para, it is the dichloro is there, student, dichloro. Then it is diphenyl, it is tetra, student. Okay, tri, not the tetra, trichloroethane. This is the trichloroethane, right? So this is what, student, that is what is called DDC, diphenyl trichloroethane. So this is what this was the quite important one. Now when you are treating with the chloroethane with the magnesium, so what is the Grignard reagent is going to form, student? So this is Mg and here is Cl. Now ammonolysis, if you are treating with the ammonia, student, so simple, it will form the aniline, student. Here is the NH2. This is aniline. Now if you are treating the RX, student, with the sodium, so this is the Fittig reaction, student. So it will give the R which group. Here is the Cl, na? So R is going to attach on this position. Now in case of Fittig reaction, student, Fittig reaction. So Fittig reaction, you need to take the 2 molecules, student, right? So here is there Cl, then you take the 2Na, again here is Cl, then you can take here is, student. So this is going to be out, student, okay, dry ether. So what the product you are going to get, student? This. So this is what, student, that is called biphenyl, student. Okay, now they are saying here Fittig reaction, that is we have done, student. Now what we are doing, you are treating with the NaOH, student, 323 Kelvin and 300 atm pressure, student. So let us see, here is the chlorobenzene is there, student, chlorobenzene. Here will be the Cl. Here is, student, chloro, and with the chlorobenzene what you are treating, student, okay, NaOH, right? Chlorobenzene you are treating with the NaOH, student. And what is the NaOH? 623 Kelvin and 300 atm pressure. So what will be there, student? It is going to give the phenol, student. This is phenol, chlorobenzene, and here is phenol. So this is all about the chemical properties of what, student? That is called the chlorobenzene.